So today, once again, I welcome all of you to our lesson for the day. And today we have a joint variation. Joint variation. Joint variation. What are we talking about here? Even the name gives you an idea of what we are talking about. Joint variation. One thing cannot join to itself. So there are several things now involved. Let us consider three variables or three quantities: x, y, and z. X, y, and z. Now suppose we have a situation where x varies directly as y, but varies inversely as z. Look at it again. X varies directly as y and varies inversely as z. A situation like that is an example of a joint variation. It's an example of joint variation. Suppose that x varies directly as y and inversely as z. We write okay. Suppose that x varies directly as y and inversely as z. This is an example of joint variation. This is an example of joint variation. We write x varies as y over z. Please take note. And x is equal to ky over z, where k is equal to a constant. This is an example of a joint variation. X varies directly as y and inversely as z. It is written in this form, followed by an equation involving a constant. In such a case, we are given conditions which will enable us to find the value of the constant. So we take an example. What example? X varies inversely as y and directly as y and inversely as z. So, if we are asked to solve this as a problem, we are told that x varies slightly as y and inversely as z, which is an example of a joint variation. We are given the values of y, z, and x. That is to enable us to find the constant of the variation. We have to find the relationship between x, y, and z, and to find the value of x when y is 5 and z is 9. Now, by way of solution, x varies as and x is equal to where k is equal to a constant. With the values of x, y, and z given to us, we can now find the value of k. When x is equal to 42, y is equal to 7, and z is equal to 3. That is 42 is equal to 7k over 3. By substituting in this equation, 42 for x, 7 for y, and 3 for z. From here now, 7k is equal to 3 times 42. That is, k is equal to 3 times 42 over 7, which very clearly gives you the value of k as 18. Which gives you clearly the value of k as 18. So, the formula that connects x, y, and z, which is what we are asked to find in the A part, or to follow the instruction properly, the relationship between x, y, and z is what? Now that I've got the value of k, it is no longer this now, but x is equal to k is 18y over z. This is the relationship between x, y, and z. And now the B part. Find x when y is 5. When y is 5, when y is equal to 5 and z is equal to 9, what do we have? We are coming back to this. We are given y, we are given z, so we can find x. We have x is equal to 18. What is our y there? 5. What is our z? 9. And what does this give you? 10. X is equal to 10. X is equal to 10. When y is 5 and z is 9, x is equal to 10. And so this is an example of joint variation. I thank all of you for listening. And may God bless you. In our next lesson, we are going to treat partial variation.